Welcome back! For today's episode, we are going to unlock all of the secrets of graphing. Now, I will let you know you've been doing the boring way of graphing, and hopefully after today, you will very rarely need to graph using a table. But in order to figure out what the secret is, we need to use tables to find that out. So, go ahead and work with your nearest partner, which is me across the internet, and underline our central question. How can you describe the graph of an equation of the equation mx plus b? So learning how to describe this whole equation mx plus b, y equals mx plus b. I hope you have dreams about y equals mx plus b because this equation will never leave you. It won't haunt you, it will always be there for you. Think of it that way, it's much more positive. Now, with each of these here, we're going to graph the equation, find the slope of the line, check, and then lastly, find the point where the line crosses the y-axis. That's the up and down axis. So these last two things are very important. Finding the slope of the line and finding out exactly where the line crosses the y-axis. Now, let's take a peek at our first equation. I'm keeping these rules in mind. Alright, so we have our equation here. We have y equals negative 1/2 x plus y. Time to do our table. Yay! So we'll have our values for x. I'm going to do this for you all, the actual equation. So that would be negative 1/2 x plus 1. And then lastly, whatever y value it spits out. This thing's like a machine, and it'll give us things. Now, I want to use values that are going to give us whole numbers. So the denominator of the number right next to x happens to be 2. So I'm going to plug in for x negative 2 because of what that can do. 0, because that's mega easy. And lastly, 2. Those are three good values. Using 3 values is always a great thing. So if we plug in negative 2 for x, we get negative 1/2 parentheses negative 2 parentheses plus 1. Negative 1/2 times negative 2 would be positive 1. That's 2 negatives, and if you combine 2 halves of something, you get a whole. So we got 1 plus 1 is 2. So when x is negative 2, y is positive 2. If we plug in 0 for x, parentheses 0 plus 1. 0 times anything is 0, so we're just left with 1. Lastly, when we plug in 2 for x, we get negative 1/2 times 2 plus 1. 1 negative in the whole bit, so that would just end up being negative 1 plus 1, which is 0. Alright, we have our 3 points. Now let's go ahead and add these to our graph. So we can go over negative 2 to the left, and up 2, a nice point, and we go over 0, up 1, and then over 2, 1, 2, down, none. Oh hey, that's looking like a nice straight line. Little arrows here. Alright, I hope that you use a straight edge, a straighter edge than mine. Alright, some important things here. Let's get the slope. What is our change in y over our change in x? Well, it looks like if we go from this point to this point here, if you see on your screen, it goes down 1 and then it goes over 2. And then again it goes down 1 over 2. It probably would go down 1 over 2. The whole thing is down 1. So we have negative 1. That's a change in y over change of x as it goes over 2 each time. So that would be our slope. Now let's figure out where the line crosses the y-axis. Here's our y-axis, the thing that says y, and look, it crosses at the point. This point is 0, 1. So down here we can write, right underneath our slope, 0, 1. Now, I'm not going to tell you yet, but I want to see if you notice a pattern. Where do we find 1/2? And where do we find 1? That number 1 right there. In our original equation. All right, let's take a peek at our second equation over here. I'm going to write our little table off to the side. We have x, our equation, negative x plus 2, and whatever it spits out. It'll be an easy one, negative 1, 0, 1. When x is negative 1, negative, parentheses, plug in negative 1 plus 2. Hey, a negative and a negative is a positive, so that's just 1 plus 2, or 3. When x is 0, just get 0 plus 2, we're left with 2. And lastly, when x is 1, we'll have negative, parentheses, 1 plus 2, so that's negative 1 plus 2, which is actually just 1. Let's plot our values. And we'll see that we get when x is negative 1 over negative 1, y is 3. When x is 0, y is 2. When x is 1, y is 1. 3 beautiful points. A beautiful line. All right, we've graphed it. Now let's get the slope. Looks like for every time it goes down 1, it changes over 1. Down 1, over 1, down 1, over 1, and so on. So our slope would end up being change in negative 1 over 1, or that just equals negative 1. Okay. Well, let's look at where it crosses the y-axis. Crosses the y-axis right here, and the name of that point is you go over 0 and up positive 2. Where do you see negative 1 in this equation, or just a negative sign, and where do you see the point 0, 2 in this equation? I'm now going to leave you with a choice. A choice to either apply our new knowledge or to continue graphing tables like we've been doing. I am losing my likeness for tables, so I'm going to give you a hint. I want you to look here at this number that's next to x, the negative sign. And I want you to look at this number that's here, this minus 2. Now, let's see how they're involved if we were to graph this. So this is the last table I'll end up doing. So if we have x and negative x minus 2, and y, what it spits out. Let's use negative 1, 0, and then 1, our 3 favorite numbers. When x is negative 1, like negative, parentheses, negative 1 minus 2. Negative times a negative is just 1, so 1 minus 2 is negative 1. When x is 0, we got 0 minus 2, we're just left with it's negative 2. And when x is 1, negative 1 minus 2, or negative 3. Let's look at the slope as we graph these things. So when x is negative 1, y is negative 1. When x is 0, y is negative 2. When x is 1, y is negative 3. So beautiful line, it creeps up through here. And you'll see here that it changes down 1 over 1, down 1 over 1, down 1 over 1. Or it has a slope of negative 1 over 1, or just negative 1. See, negative 1 over 1 equals 1. Where do we see that number? Looks like, oh, there's a negative 1 right next to x. Just like last time when the slope was 1, there was a negative 1 next to x. In fact, I even want to show you that in the very first problem we did, our slope is negative 1/2, and look at the number that's next to x, negative 1/2. Interesting. All right, well, let's look at our y-intercept. Where does this line cross? Crosses at 0, negative 2. So when x is 0, y is negative 2. Where do we see negative 2 except that right next to whatever number is being added or subtracted from x? Ha! We're on to something. Hi, Leckler. Hi, Johnny.
I got my keys in my room. So.
Johnny. Oh, hey, buddy. Oh, you see food.
Johnny. It's burning the midnight oil or whatever.
Yeah. Make a little math video for tomorrow. Buddy.
Nah.
No. Well, have fun, you two. Alright, I'm back. Johnny's a nice dog. Last thing I want you guys to do here is to graph D on your own, but I want you to look at what number is next to X. That might be the slope. And what number is being added or subtracted to X. That might be where it crosses the Y-intercept. But I still need a line there with that slope and going through that point. You could always make a table. Okay, this part here has a few of the problems you just did on the last page, namely 1A, B, C, and D. You see this over here? For every single one of these, the description of the graph is just a line. Yep, a line. Because what does it look like but a line? Yay! Now, it asks some more complicated questions here of the slope of the graph. Now, you already wrote that down before. The slope was -1/2, if you remember from the last page. And the point of intersection with the y-axis, or where it crossed that y-axis. And you remember it was 1. So for all of these, you've already done this. We have line. We know our slope was -1, and we know it crossed at 2. At a point of intersection, sorry, that would be 0, 1. This one would be 0, 2, line, -1, and 0, -2, last line. If you didn't know that, well, now you do. And y-intercept of 0, 1. So now that we're starting to see the pattern, let's look at some that we didn't do, and let's just get the y-intercept, the slope, and a description of it. Now, this one looks normal, number 6, just like we've been doing, so we know it's going to be a line. I remember asking, what's that number next to x? What number is always hiding out there, whether or not you know it, being multiplied against you? Hey, 1. See how it's just x plus 2? So the number that's right next to x would be 1, and whatever number is being multiplied to x is the slope. What number is being added to x? Hey, 2. So that would be the point 0, 2. That's where it would cross the y-axis. Graph it and prove me wrong if you think that's not right. So this next one, line. The slope is going to be just like number 6. And it's going to cross the y-axis at a point very sort of similar. Whatever number is being added or subtracted to x. If you see number 8 is very similar to number 2 and number 5. In fact, it has the same slope as number 5. And the y-intercept would be whatever number is being added or subtracted to x. Starting to see a pattern. Go ahead and fill out the rest of this following that pattern. All right, got a little bit of writing here to sort of wrap up what we learned, what we discovered. This asks us, how can we describe the graph of an equation? Well, the equation y equals mx plus b. Notice there's no exponents, so we know that it's going to be a line. So a line. And we know that the slope is going to be whatever letter m is. So we can say with a slope m, and we know it's going to cross at the point that's and crosses y-axis at, it's always going to be 0 for the x-axis because that's how it crosses it, and then whatever number is being added or subtracted to x, or b in this case. So we have a whole description. A line with a slope m and crosses y-axis at 0, b. This next one, I'm sort of going to talk through this. How does the value of m affect the graph of an equation? As that value gets bigger, what have you noticed? So once it gets to like 1, 2, 3, 4, and 5, what happens to the line? Or even negative 1, 2, 3, 4, 5. Versus like 1/2 or a quarter or an eighth or maybe like 1/16. What happens to the steepness of the line? For b, how does the value of b affect the graph of the equation? So if you noticed, if you look back on a few things that you've graphed, that number that's being added or subtracted, 2x, how does it affect the graph? Perhaps it's graphed higher or lower on the y-axis. If you'd like, you can check your answers to part A and B with 3 equations that are not in that giant table, but you don't have to if you wouldn't like to. And lastly, why do you think the equation y equals mx plus b is called the slope-intercept form of the equation of a line? The idea slope-intercept. Like to intercept something is to cross its path, or in this case, perhaps cross an axis. So it's called the slope-intercept form. Why do you think it's called the slope-intercept form? Go ahead and write that down here. Well, it's been grand, team. I will see you in class.